Welcome to Who Gives a Shift? We are going to talk about autonomous agents, co-pilots, and traditional automation, and how they all work together in this brand new world that Microsoft has brought to us. Before we kick off, I do want to just thank the sponsors and the organizers. It takes an immense amount of work to put on an event like this. Thank you. All right, well, let's get into it. How many of you know who this guy is?
Nathan Rose.
No. I have better hair. So Johann Pachelbel was a composer who lived about 400 years ago. He lived in Germany. He's kind of a big deal. He's kind of the godfather of modern pop music. He wrote a song called Pachelbel's Canon, or the Canon in D major. And this is the template for almost every pop hit you've ever heard. So we'll be kind. I'm going to try my best. So if you've ever heard it, so it basically descends down the D major scale, and the bass line goes like this. Ugh, not like that. Sound familiar? Maybe you've heard that on a clock at your grandparents' house or something like that. And then the melody goes like this. And then we put it together. This is how it sounds. Sound familiar?
Nathan. So they can't hear the music from the keyboard on.
Yeah, Teams will block it out. Sorry, guys. That's why you show up in person.
You can sing along.
So feels like somebody's about to get married right now, right? This is the Canon in D major, and Pachelbel doesn't like to brag. He's German. That's just how they are. But he pretty much influenced most of modern pop music. See, kind of an interesting history behind this piece of music. So it was written in the late 1600s, early 1700s. We're not quite sure. Pachelbel died in 1706, so it was written sometime in that period of time. And then something really interesting happened after he died. Everybody forgot about it. This piece of music that is well-known, well-loved, influenced all the songs we love, was completely forgotten about, consigned to the dustbin of history. And it probably would have stayed there because that's usually what happens with one-hit wonders. But then in the mid-1900s, something really interesting started happening. There was a paradigm shift in music. We started moving from this kind of rigid orchestral music to styles like jazz and folk and rock and roll that prized adaptivity, flexibility. And that was about the time that this piece of music was rediscovered. Artists started to re-record it. People started to study it. Then by the 1970s, it was everywhere. You heard it in almost every song you ever loved. And we probably sitting here thinking, well, why? What's so special about it? Well, if we dissect it, buried in this canon in D major, is this chord progression. So let me go ahead and play this as chords. This might start to sound a little more familiar. That sounds a little more familiar to you. There's something even more special going on in here because Pachelbel either invented, unwittingly discovered, came across pop music gold. Because buried deep in here is the 1, 5, 6, 4 chord progression. This is the recipe for every pop song you've ever loved because it sounds like this. Sound familiar? Starts to sound like things you've heard before? Now we can shift it down to another key, and you've definitely heard that before because that's pretty much every pop song ever. He's buried this 1, 5, 6, 4 chord progression in his canon. And this is the recipe, as I said, for pretty much every pop song you ever loved. If you've ever seen the Axis of Awesome on YouTube, they have a video called 4 Chords where they illustrate this very thing, where they play through these 4 chords. first. And pretty much everything you've ever loved is some variation of that. And so as a result, Pachelbel's canon went from this very static, very rigid piece of music with this earworm buried in it, and it exploded into almost everything you've ever loved. There's are pieces of music that span genres, artists. They do span decades, but I focused on kind of the last 20 years or so, stuff that we would know. And you can see some really interesting stuff in here. Almost all of these songs follow the chord progression that's in Pachelbel's canon. Now, there's a few songs here that I want to highlight because they directly sample this. So the first one is Graduation by Vitamin C. This was a very popular song when I graduated high school last century. They basically just ripped this whole thing off. Not like that. That's basically the chorus. The same for See You When You Get There by Coolio. He basically samples this thing and he loops through it. I do want to talk really quickly about Memories by Maroon 5. They do something really interesting with it because they take this chord progression, but they shift it to a different key. So they start on B like this. It sounds like this. And if you listen to the recording on Spotify, it kind of goes like this. The only difference is it's guitar and done by professionals. But other than that, it sounds kind of like that. Now, what's really cool about these chords is that we can be really creative with them. We can take these chords and we can break them up. Or we can rearrange them in different ways. So let's say Taylor Swift needs to write a new song because Travis lost the Super Bowl. They need to break up. And this is just a little too upbeat for a breakup song with Travis, right? So we can mix it around and we can have it a more melancholy sound. Yeah? Sad song, Travis lost the Super Bowl. Or if we really want to go for it, we really want to be melancholy, you can go like this. Sound like something you've heard before? Give you a hint, she's British. But it's rigid piece of classical music that's 400 years old, influenced just about everything you've ever loved. So, all right, Elmo, I think we've belabored that point. Let's move on. Oh, hey, Simon, how's it going, man? Power effects. Come on, it was kind of good. That's just mean. All right. Thanks, Simon. All right, so why did this piece of music have such an outsized influence? Well, as we've discussed, pop music gold, 1-5-6-4 chord progression. That is the formula if you want to write a hit song. Doesn't matter the key, just use those 4 chords and you've got a hit. The other thing is, as I alluded to, we have this paradigm shift going on in music that started around the 1950s. We started moving from traditional styles where you played everything with precision and rigor to styles like jazz and folk and rock and roll that prized flexibility and adaptability. And chords are custom designed for that. You can mix them up, you can jam, you can play around with them. So, new music styles prize this. And lastly, simpler chord notation democratized the creation of music. You didn't have to go study music theory for years and years and years to understand how to make those weird symbols on those 5 lines that we're familiar with. You just knew how to write, you needed to know how to write some chords, and you were away, you could create music. All right. So have chords completely replaced the old way of doing it? Well, something really interesting going on. You see, despite the fact that chords are really popular, and let's face it, rock and roll is a lot nicer to listen to than classical music most of the time. Chords have not replaced traditional music notation, not by a long shot. These two coexist, because depending on what you need to do, if you need rigor and precision, let's say you're composing a film score or a jingle for a commercial that must be played exactly this way every time, you want that noted down with exact precision, so whoever picks up that sheet of music knows exactly how it's meant to be played. Whereas if you're just writing a song, and you just kind of want to get the general feeling and emotion, you can just put the chords down and whoever's playing it, it's up to their interpretation. So these two coexist. The new and the old exist together. Depending on your context, depending on what you're trying to achieve, one is more appropriate than the other. So this brings us to our big idea. There are three things that I want you to take away from today's session. This is the first. When there is a paradigm shift, like what happened in music in the 1950s, like we are seeing today on the Power Platform with the advent of AI, the old doesn't necessarily replace the new. Rather, what happens is the new expands the possibilities. We can do more things. And the key to thriving in a paradigm shift is understanding strengths of each and when to leverage them. So, that's number one. If you take nothing else away, that's the first thing. Paradigm shifts don't replace the old necessarily, expand possibilities, and the key is to learn when to leverage the strengths of each. All right. Well, as some of you know, I'm Nathan Rose. I am a solution architect at Olympic 33 here in beautiful Auckland, at least for another 7 days. I am also a Microsoft MVP in business applications. As my fellow MVP, Mary Myers, is fond of saying, how do you know someone's an MVP? Don't worry, we'll tell you. And this is a bit of a different session for me because I'm kind of known as the Power FX guy. That's usually what I do my content on. But we are seeing just this massive paradigm shift. And so my mission is to unleash human creativity via low code in the Power Platform and increasingly natural language. So I'm branching out. And Power Platform is literally the best thing ever. So this is actually aerosol cheese I got when I was in the States. It's amazing. You got to try it. Literally cheese in a spray can. It's incredible. All right. How are we going to spend our time together? We're going to start out by exploring a brief history of how we got here. How did we get to this point in history when we talk about automation? We will then talk about how agents and traditional automation differ. I don't know about you, but I kind of have this idea, like, I feel like they do different things, but I'm not 100% sure of what that is. So we'll get into that. We'll leverage a new paradigm for these two things working together. We'll talk about when to use them. Then we'll get into the new paradigm. I do have a brief case study that we'll go through, and we'll wrap up with Q&A. I love Q&A. It is my favorite part of these sessions. I get my best ideas and content from the questions that you all ask. So I love questions. If I can't answer it, I will think about it and come back to you in due course. And as always, I love for these sessions to be interactive. So if at any point in time you have a question, a comment, something you don't understand, something you don't agree with, feel free to put your hand up and let's talk about it. All right.
A surprise gift, Nathan.
What?
We got a surprise gift.
What?
We got a surprise gifts for the audience, whomever can answer your question.
Oh.
Yeah.
I don't have any questions.
Yeah, for you if you ask questions.
If somebody asks me a hard one, I'm probably going to be like Clive, Rami. So, all right. How did we get to this point in history? Well, pretty much for most of human history, from day one until the Industrial Revolution, things were manual. Productivity gains stopped with the invention of the wheel. We used manual tools. This is where we get terms like horsepower and manpower, because that's what powered machines, people and animals. And so we weren't terribly productive. Life was hand to mouth. You pretty much survived to grow enough food to keep you alive, to grow more food to keep you alive. Fun times. Then in the 1800s, the Industrial Revolution starts. It's the electromechanical era. We discovered how to use steam and coal and recycled dinosaurs to create energy for our machines. This is what created the era of abundance that we live in today. We can make far more stuff than we can possibly consume because we've created very efficient machines that can do that. We don't need as many people on the factory floor as we once did, but this era created the need for knowledge workers and administrative people and a lot of the jobs that you and I see today. That was the electromechanical era. Then in the 1950s, because we've created all this knowledge work, computers enter the workplace. And we needed to program them to do stuff for us. So we get to this age of programmable automation. This is the era, you and I know this world very well. This is our bread and butter as Power Platform people. Linear automation, trigger, input, do stuff, output. So it started with punch cards. It's culminated with Power Automate. This is the era of programmable automation. It's still around today. Sometime within the last few decades, AI started to enter the scene. Not the AI we're about to talk about, some of the earlier versions of AI. This is the early versions of AI Builder, some of the Azure Q&A Maker stuff, the Azure Documents, Azure Images. And what it could do was start to enhance our automation. Do things like look at a physical document, extract parameters from it, and then pass it on to programmable automation. This is the automation that looks at your X-ray and spots the nasties. That's been happening within the last couple of decades. And then in November 2022, ChatGPT hit the scene. We lost our collective minds. We are now in this era of autonomous agents. This was announced last year definitely at Ignite. I can't remember if it was at Build, but we are now in this age where AI can do stuff on its own. Now, I don't know about you, but a little confusing, right? This used to be a little bit easier because broke things down broadly. Pilot responded to prompts, and Power Automate did stuff. Now, I'm grossly oversimplifying here because Pilot can call flows and do stuff. And as Rami showed us, there's a lot more ways to automate than Power Automate, depending on what you're doing. But those are the broad buckets. AI answered questions, automation did stuff. That was cool. Till right before Christmas break, our own Satya Nadella sat down for an interview and all pandemonium broke loose. See, he declared that SaaS as we know it is dead. No more SaaS. It's all going to be agents. Because agents can do stuff. Now, this is where I started to get really confused and perplexed because automation does stuff pretty well. So what does it mean? Agents do stuff. So we have a quandary on our hands. Spent quite a bit of time thinking about it. That's not an accurate representation. And
Yes, Prince.
traditional automation does stuff, right? Now we're being told autonomous agents do stuff too. So how are they different? Are they different? Are agents just the next iteration of Power Automate, and we're all going to be doing that instead of Power Automate? Are the differences? What are they? So let's get into it and explore. All right.
Can I
I said there's three things. Yeah.
the bottle?
What? You're not old enough. All right. I said there's three things that I wanted you to take away from today. The first was paradigm shifts don't necessarily mean the old replaces the new. The second is when we think about agents and traditional automation, your traditional automation is like classical music, like the symphony orchestra, and agents are rock stars. And so we'll get into exactly what I mean by that just now. All right, so we've got automation and we've got agents. Traditional automation, agents, and they both do stuff, right? How are they different? What is the difference between these things? Well, when we get into it, there's actually some really interesting differences. Start with automation, rule-based. It will always do exactly what it is programmed to do. If it is going to add numbers, it will only add numbers. If it produces decimals, it is only ever going to do that. It won't produce a string. Deterministic, which is a similar type of thing, but it's only going to do the output. The output is preordained. If that thing was set up to produce a decimal, that's all it will ever do. Precise. It runs exactly as specified. Creativity here. Static. Traditional automation doesn't change unless people like you and me get in and start upgrading it, which is always a bad idea on Fridays. It's static. And then lastly, non-adaptive. Doesn't learn. It just does what it does. All the adaptations are done by the human systems analyst who looks at the logs and determines where it could do things better. Okay, what about agents? Well, they're not rule-based, they're goal-based. They're not given a precise set of instructions. They're given a job description like a human is. Next, they're context-aware. In their job description, they're told, you're part of the customer service team, you're part of the sales team, and they're given knowledge, and based on this context and knowledge, they put that together to start to do stuff. Handle uncertainty. There's no uncertainty in the world of traditional automation. You only ever feed the parameters into it that it's expecting to get. Whereas an agent will be asked anything, and its job, use its context, use its knowledge to determine, can I answer this? Then they're adaptive. So built in to the agents is this self-learning mechanism so they can see how they're performing, what works, what doesn't, and they get better with time. This is the difference between agents and automation, but it's still kind of high level. Let's come down a level. Let's get a concrete example. And in order to do that, we need to take a trip back to 6th grade math class. Any of you good at math? I know Indira is, but I hated math. I was so bad at it. Kind of ironic given what I do for a living today. But remember in math class, you got two different types of homework problems. The first type of problem you got, on the page, there would be numbers and symbols. Based on that, you would add, divide, subtract, multiply based on those numbers and those symbols. Sometimes there'd be a combination. You'd have to do multiple operations. All you did was follow the instructions on the page. That was how you did your math homework. So that was the first type of problem. Anybody remember the other type of homework problem? All right?
String ones.
Uh,
String ones.
Yeah, word problems, right? Dreaded word problem. Hated these things too. I was so bad at them. You'd be given a paragraph. You'd have to read it, and you'd have to figure out what you were supposed to do, right? So, believe it or not, it's going to blow your minds. Despite the fact that none of this stuff had been invented when any of us were in school, your teacher prepared you for the world of agentic AI. Because guess what job you did when you solved a word problem? You were an agent. All right, let's break it down. Got our word problem. So let's look through it like an agent would. We need 3.5 cups of flour to make a single batch of cookies. We need to make 4 batches of cookies. And so we want to know how many cups of flour we need in total. Now, the fact that it's for a school fundraiser is irrelevant. We can ignore that. We start pulling this stuff out. 3.5, 4. We need to multiply it. And we decide that this is the problem that needs to be run. Guess what all this stuff is? Parameter, process, and decision. You've done the job of an agent before when you solved a word problem back in school. That's what it's doing. All right, so let's put this into the jobs of agents and automations. Take our word problem and let's put it in an agentic context. What did you do when you solved it? Well, firstly, you were goal-oriented. You were told you had to read this thing and solve the math problem. It's adaptive. The more of them you did, you got better at it. I didn't, but most normal people do. Context aware, you're told that we're doing math. We're not correcting the grammar. We're not rephrasing it. We're not making it a catchy LinkedIn post. We're just extracting stuff to do math problems. And we can handle uncertainty because we don't know what we're going to be asked to do. We could have read something that said she wants to make one batch of flour, one batch of cookies, or she wants to divide or something like that. So, pulling this stuff out. So again, agent. We pull it out. Got 3.5. To multiply it by 4. So this is what we need to run. But now that we've pulled these out as an agent, now we can put on our automation hat because 3.5 times 4 is always going to equal whatever it equals. If somebody knows the answer, call it out. I have no idea what it is.
14.
What?
14.
Okay, somebody fact check him because I can't. All right. So now we put on our automation hat, right? Because once we're doing multiplication, we're rule-based. 3.5 times 4 always works the exact same way. I tried, believe me, I did some creative math homework. It didn't work. So deterministic. Multiplication is always going to produce an integer. Not adaptive. We're not really learning. We're just cranking the numbers. Static. Those parameters, that process is not going to change unless we read it again and decide we need to do something else. And it's precise. So that's the world of automation. And so we start to get this view how agents and automation can coexist because they do stuff, but they're doing fundamentally different things in different ways. All right, so when do you use them? Well, start with automation. Use this when the process is stable, predictable, rule-based. And Rami is getting a passport set up. We don't want an agent figuring out what to do. We want to follow the rules to make sure that there's no fraud, to make sure that it's done properly. Same with the input and the output parameters. Automation is not set up to take different kinds of parameters. If we need a string, that's a different automation than if we need a decimal over here. So predictable process, predictable parameters. Simple filtering. I'm going to get into this in a second. This is kind of an interesting one. When we have to put in things like switches and if conditions, we can handle simple stuff in traditional automation, but when it gets really complex, it starts to get messy. And then this is another interesting one. When we need transparent how and why it did that, we need to use traditional automation because when an LLM does something, we're not really sure why it came up with that. But before that freaks you out, kind of the way you and I are, right? Why did we say or do or think? We don't know, we just did it. And AI works exactly the same way. When you need that transparency, you're going to need to use traditional automation. All right, what about the agents? Again, agents, automation, classical music, rigid, precise. All right, the agents need to be used when we need to determine what needs to happen. Think back to the word problem. When we read it, we determined that we needed to multiply some stuff. And with the parameters, we determined that we needed 3.5 and 4. Cookies were, and school fundraiser weren't relevant. And then when we have more complex filtering scenarios, we're going to get into this in the case study. Say, for example, we have SMS or WhatsApp replies coming in. Business process is anything that's not a yes is a no. Sounds really simple, right? But when you're dealing with unstructured data, no could take on many different forms because English is a gloriously unspecific language. And we can do exception handling. Something automation does really well is throw exceptions, but it's not really good at fixing them, right? It's just good at saying, there's a problem. What an agent can do is it can start to look at the error message that was thrown. It can look at the input parameters and what was going on, and it can determine what needs to happen. If we accidentally passed a string to this thing, it was expecting a decimal. Let's reformat it. Or there was a downstream process that was offline at the time, and it's not scheduled to be back online for an hour. We'll retry then. These are the kinds of things that agents can do. So agents, rock and roll, flexible, adaptive, creative. All right, let's talk about this case study. So I built a demo for this a few days ago. I don't think we're going to have time to get through it. But in Customer Insights Journeys, you can create a custom channel to send SMS. Now, here in New Zealand, that's our only option because we can't use Twilio. And one of the limitations of custom channels is when you want to use keyword responses, you can't do that. It's not supported. So if somebody replies no or yes and you want to automate something, that doesn't work out of the box. You've got to use Power Automate. It's Army knife for the Power Platform. You can custom build this. But again, anything that's not a no is a yes. Well, that's really confusing, right? Because no could take on many different forms. Beyond that, if we try to account for that in our automation, we're going to start breaking all the principles of solution architecture. We're going to have so many child flows or the world's biggest switch condition that it's going to be unmanageable, not modular, unmaintainable.
We know. We know.
Exactly. So that's the problem that we're up against with traditional automation. Guess what agents do really well? Language. They're really good at understanding language, and they can understand intent. So if somebody gives a more ambiguous response, can determine, is that a yes or is that a no? So we can start to simplify our automations. We throw an agent in there to say, what's the intent behind this message, and then route it here or there depending on what you think is going on. So we get simpler filtering. And once we know what needs to happen, then we can hand off to the automation, because automation's really good once it knows what to do. This brings us to our new paradigm for automation. When we already know what to do, use automation as we've known it. So when you know what needs to happen, we know the parameters, we know exactly what needs to happen. Like in the math problem, we know we need to multiply 3.5 by 4. That's the world of traditional automation. When we need to decide what needs to happen, that's the world of the agents. So this is the third thing I want you to take away. When you already know what needs to happen, you don't want to use an agent for that. So you don't want an agent running payroll. But you do want an agent deciding whether a customer query needs to go to the customer service team or the sales team. You do that really well. So, and they both do stuff. So in this new paradigm, automation and agents aren't at odds with one another. They're best friends. You can't go do karate in the garage because they are software, not stepbrothers. If you know, you know. But this is the new automation paradigm in the world of agentic AI. Right. Brings us to the end of our time. Wow, we really flew. So, seen that traditional automation is like classical music. It's precise, it's rigid, it follows a specific pattern, works the same way every time. AI automation agents is like rock stars. It's adaptive, it's flexible, it's given a broader job description. And we've seen how to leverage this new paradigm in this world of agentic AI, that when we need to decide what to do, use an agent. Once we've made that decision, pass off to automation. So that brings us to the end of our time. Thank you all so much, and I'm happy to take any questions.